The average daily temperature T in degrees Fahrenheit for a city as a function of the month of the year M can be modeled by the equation T equals 35 cosine pi over 6. Well, you see the equation, where M equals 0 is January, M equals 1 is February, M equals 2 is March, and so on. Which equation also models this situation? Okay, let's do a rough sketch of the equation that they gave us, and then see how that compares to the others. Okay, I think we're gonna have to look at phase shift this time. We'll see. So the equation that they gave us is a cosine function with a positive a value. So if there was no phase shift, if I ignore the plus 3, and obviously I'm ignoring the plus 55 for the moment. I mean, they all have the same midline, so let's just, if it makes you feel better, call this 55. Okay, anyway, cosine starts up high, and then it begins to fall, and then it gets to its lowest point, and it comes back, and then it ends high again. So that's how it would look, something like that, if there was no phase shift. However, this m plus 3 right here is actually left 3 months. Okay, so I'm just going to erase this and shift the whole thing left 3 months. So I'm going to need some extra numbers. So 1, 2, 3. Okay, so that means my cosine is going to start here, then it will go here, then it will go here, then it will go here, and then it will be back. Okay, so this is what my cosine function will actually look like. Alright, so the question is, which one of these functions is doing the same thing? Now, let's look at the first one. Let me change colors. The first one is a sine function. There's no phase shift, so that means it would have to start right from the origin, but then it's a negative a value. So normally the sine function starts at the origin and it goes up and it goes back down. Alright, that's like y equals sine theta. But if you have y equals negative sine theta, then it starts at the origin and it goes down and back like that. So that's what's happening here. It should start at the origin and it should go down and back like this. And that is exactly what's happening. So I think we found our answer right here. I think the answer is going to be A. Okay, if you follow through and looked at the rest of these, for example, look at this one, look at the third one. It's the same as the one I picked, except it's positive. So that would mean that it would start at the origin and it would go up like this. But that's not what happened. So using that kind of thing, that's how you know that these are wrong. Also, the sine function has to start at 0, 0. So there can't be a phase shift because that would move it away from 0, 0. So that would eliminate the other two very quickly.